Okay, so welcome everyone on the IT and software engineering part. Here we're gonna develop more concepts about IT to help you during the exam for DSTI entry. And I will start with software engineering explanation. Here we're gonna talk about the design of software and more accurately about the abstract class. So to explain what is an abstract class, I will take the purpose that you understand OOP, so object-oriented programming, and for that I will start from an object class and the design of virtual software to explain how we arrive to the abstract class. So let's take, we are working on a software, we would manage a farm, so with animals. So we are in a world where everything is object. So the first thing I would like to manage, it's my animals. So I will create a class for each animals. So let's say in our farm, we have some cow, some pig, some duck, and some dog, to be sure. Let's say, yeah, some dog to manage the other animals. So in our class, so this is our plan to manage our animals. We know each animal, because we are a small family farm, we want all our animal have a name. So name. We want to know the weight of each animal. So it's a float. So now we have what we call our attributes. So what that describe our animals, and so our cow, our pig, our ducks, and our dogs. We want to make some functional programming, and I would like my cow is able to eat. Move. And let's say talk. It's not talking, but let's say I want to. Same for each of them. So talk. Move. And talk. And same for my dog. Talk. So as you can see, I need to declare in each of my in each of my animal here, the name, the weight, the name, the weight, the name, the weight, the name, the weight, each time. And it move talk, it move talk, it move talk, it move talk. And by example, we know that our cow and our dog is walking in our cow, pig and dog is moving in the same way or eating, and all my animals quietly is eating in the same way. So I should do copy paste of my code, and it's not a good idea in software engineering because if you do copy paste, it means you need to maintain each time you make your copy paste the code. If you want to change something, you have to change it at 1, 2, 3, 4 places. So how could you resolve this issue? It will be to create a upper class, a parent class. So here, as you hear me since the beginning, I'm talking about animals. So I will create my class animal. With a name, weight, and um, my function it move and talk. Um, the issue here is, as I said, we talk everything is object. If you have an object, you did, so here is my class, the plan. And if I want to create an object with my plant, I just have to instantiate it. So most of language use a new name of the class and you create a new instantiation. But here's the issue, it's you cannot define what is an animal. If I ask you to show me an animal, you will not be able to show me an animal without showing me a dog, a cat, a pig, a duck, a chicken, or anything else with a children, with not just an animal. An animal, it's what we call an abstract concept. It's something you cannot visualize. You cannot visualize, so you cannot instantiate it because you cannot define it concretely. So I have my animal, so I will do it an abstract class. So this will be abstract. So I know that my cow, pig, duck, and dog have their own way to move, their own way to eat. So if I would add fish, I could not define directly a way to let them move or eat, because each cow and pig have the specificities. But what I'm sure is that every one of them is able to do those actions. They're able to perform it. So the idea here is I will make a minified version because I won't add some stuff. So co pig duck dog. And I will make them all inherit from the animal class. And here I will be able to use the overloading to concretize the function eat, move, talk. Because as I cannot concretize them directly in animal, I will put them as eat, move, as an abstract function. So here I have a semantic relation between a pig, duck, dog, cow. They are all animal, so they are all a specification of the animal class. But I know they are a functional part of the. They have a functional way to work that is different for each of them. So the idea here is to implement this functional part in the concrete class and let the abstract class define the description, so the attributes, the common attribute, and the common characters and mechanics of every animal. So this is the role of abstract class. An abstract class use the fact that you have a semantic relation between both of them, and not only an action relation. By example, a bird and a plane can fly. So you can create what we call an interface flyable with the function fly. And you will be able to put it to a duck, to a plane, to an helicopter, or any flying object without semantic relation, just an action thread. This is the difference between an abstract class and an interface. So if I check your questions, from exclusive design point of view, putting aside all specificities of any given object-oriented programming language, what is the purpose of an abstract class? Abstract class define a common part to a class hierarchy from which the functional aspect is resolved by the children class. If you check, you have all the words I used during this explanation to answer to the question. Okay, welcome everyone. So here we're gonna talk about networking, and we're gonna talk about the IP and how communicate in network and subnetwork. So the first thing I need to define what is a network. So a network is a way and a tool to communicate between two machines. So Alice is a student at DSTI. Bob is another student at DSTI, and they want to communicate between them. So Alice, Bob. So we're gonna use some electrical communication. I don't want to talk about electrical mechanism and electronics mechanism. I will really stay on the software part. And we're gonna make a wire and a connection between both of them. So Alice and Bob want to communicate. So Alice wants to send a message to Bob. So Alice need to know how to communicate with Bob. So she need an address. So Alice will use the MAC address. So MAC address is a unique address for each network interface. So Alice and Bob will use a MAC address. So a MAC address is a unique identifier for each network interface. It's unique. It's provided by the constructor of network interface, and this allows you to identify your. It will allow you to identify your machine everywhere in the world. You know this interface, network interface, is unique. It's yours, and it's composed of 6 bytes. So, by example, let's make 2C 5488 59 AD B2 1 2 3 4 5 6 5 6. And for Bob, we're gonna use 1D 5489 A1 BC 32. So now they are connected only on the same network. They are only a wire. Alice just have to send his message to Bob by setting the address, like you will do if you want to put later in the letterbox of your neighbor. You take your letter, you go and you put it inside. So you know the address of Bob, so you can send it directly. And Bob can do the same. He can send back a letter, so what we call a packet, to Alice. So by using the MAC address of Alice, and Alice the MAC address of Bob. So now let's make it complicated. So if I want to make an illustration about it, this will be a unique identifier like the number of your street, because you are only on one street. Now I will make it more complicated. I will add Alice and Bob. And I will add a new router, so a machine like your box, by example, if you're in France. And the router will be open to let everyone who wants to connect to the network be able to connect to this network. So you have the MAC address. We call MAC1, MAC2. And let's say you have a new student, your friend Charles, who come add to the network. So it just plugs to the router by Wi-Fi or wire. And you are Charles with MAC3. So now, if they want to communicate, what will do the router? It will use a protocol called DSTI to allow you a new type of address. So this is a private address. So it will be, by example, this one 192.168.02 for Alice, 192.168.02 03 for Bob, and 192.168.0.4 for Charles. And you will see the router will take an address that we're gonna call 192.168.1.0.254. That is his own address. So now, because the MAC address is unique to each device, and I need the router should know where to communicate. So what you need to do is to link this virtual address, what we call an IP, Internet Protocol address, to my MAC address. So I need to link in a table with here it's IP1, IP2, IP3, and IP4. And my router will create a table with MAC and IP. So here I will have MAC1 attached to IP1, MAC2, IP2, MAC3, IP3, and MAC4, IP4. So when a new people, let's say Didier, so a new people arrive on the network. So it's this time Didier. Didier have his MAC, its own MAC address, so MAC4, MAC2, MAC4, no, MAC4 is here. So here it's MAC5. And Didier want to know who is on the network. So it will start an IRP address. So everyone will start an IRP address, an IRP request, so ARP. And everyone will say, okay, I'm this IP and I have this MAC. I'm this IP and I have this MAC. I have this IP and I have this MAC. I this IP and I have this MAC. And DTA will send, okay, I have this MAC, so attribute me an IP. So MAC5 and IP5. So here, everyone have an IP address. So everyone can be able to communicate between them without asking or completing each time the MAC address. You can use to know if who you are communicating with the IP address. The IP address have another interest, and we're gonna talk about it in a few minutes. I will just explain before how work an IP address. So an IP address, as you can see, I will take this one, the one of Alice. As you can see, there is four numbers, sorry. There is 4 numbers, and this is why we call it IPv4. IPv4, it's for 4 bytes, so 1 byte. So what is a byte is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So here it's 1. So if I want to repeat it, here it will be 1. So here it will be 0, so 0, 0, 0. Here it will be 1, 8, 128, plus 0, so 32, 1, 16, 8, 4, 0, 2, 1. Okay, so here it's 184, so it's 1, 64, so 1, 1, 680, 80, 80, okay, 0. So this is the value in binary of my IP address. It's important to understand this is a byte and this is bits. This is a bit, because this will be important when you will work with network. So now let's complicate it or schema. You have the network, so a router, remember, with so this is the router where is Bob, Alice, and Alice, Charles, and Didier. And this is a new network, so it's connected by a wire. So where here it's here you have Ernest, Fabrice, and Gaspar. So they want to communicate on they want to communicate between them, but to do this they need to talk through the gateway. So the gateway is how you go out from your own network to go communicate on another network. So here, if we check, we have three networks. One network, two networks, and a third network. So to be able to communicate between them, they need to know if they are on the same network. So to do this, so if you want to do it, we have one network and two sub-networks. But to do this, you need to know how you determine it if you are on the same network. So you need to use something called subnet mask to know if you are a subnet. So here for this one, it will be 255.255.0.0. And for this one, it's the same, 255.255 dot zero. So how it's working? So I take my I will take the previous one where I do the byte. So here I use my subnet mask. So subnet mask. So 255.255 and 0, 0. So here it will be 1, 1, 1, 1, and 1, 2, 3, 4, 5, 6, 7, 8, 0, 0, 0, 0, 0, 0, 0, and 1, 2, 3, 4, 5, 6, 7, 8. And what you do, you will do this minus this minus this, and this minus this minus this. So you do it as a mask. Everyone on the, it's not really minus, but if you mask this and this will tell you, okay, all this part is a part of the network address. All this part, because it's 111, is part of network address. Here it's 0000 minus 0000. It told you all this part is part of the computer address, and all this part is part of the computer address too. So what is my address network here? It's sorry. If I go back here, this is my network address, and this is my network address. I do the same process. So if I can check those bus number and they are the same, because I know it's a part of the network address, this means I am on the same network. If they are not the same, it means we are not on the same network. Okay? So let's make a concrete example. So the concrete example is come from the exam. I will just modify the value. So I have my network IP. My network IP is 30.20.0.0. I need my subnet mask. So my subnet mask is net IP base subnet mask is 255.255.0, and the IP of D1. So let's call who first people D1 is and the sub IP of D2 is and we would like to know if they can communicate. So you take your subnet mask here. You check what is representing your network. So I know 255, it means the whole number represents the network. So 255, 255, 255. So this means that 192.168.20 represent my network. I can find it in D1, in D here. So it's on this network, no problem. Now, if I check on this one, okay, I got the first one, I got the second one. Oh, wrong, I don't got the third one. So this means they are not on the same network. So you will need to create a big network to communicate between both networks. So what we call internet, it's the idea of internet. It's more complicated, but it's the idea of internet to be able to communicate between D1 and D2. So if you have this question in the exam, it means the communication between both is not possible because they are not on the same network.